Welcome to our comprehensive guide on essential Java programs. In this video, we'll walk you through a variety of Java coding exercises, ranging from basic number operations to advanced array manipulations and pattern printing. Whether you're a beginner or looking to brush up on your Java skills, these practical examples will help you understand the core logic behind each program. Let's dive in and explore the world of Java programming, starting with simple number operations and gradually moving to more complex tasks. Get ready to enhance your coding confidence and problem-solving abilities. Let's begin with a classic task, displaying all odd numbers between 1 and 100. This program uses a simple for loop to iterate from 1 to 100, checking if each number is odd by using the modulus operator. If the number isn't divisible by 2, it's printed as an odd number. This approach is fundamental for understanding loops and conditional statements in Java. Mastering such basics is crucial as they form the backbone of more complex logic you'll encounter later. Building on the previous example, let's calculate the sum of all odd numbers between 1 and 100. The logic is similar. Iterate through each number, check if it's odd, and if so, add it to a running total. At the end, the program prints the final sum. This exercise reinforces the concept of accumulators and how to use loops for aggregation tasks in Java. Now let's count how many odd numbers exist between 1 and 100. This program is a great way to practice using counters. As the loop checks each number, it increments a counter whenever an odd number is found. After the loop completes, the counter holds the total number of odd numbers in the range. This technique is widely applicable for counting occurrences in various programming scenarios. Let's generalize the sum calculation to the first n natural numbers. Here, the program takes a variable n, then loops from 1 to n, adding each value to the sum. This is a foundational algorithm, often used in mathematical computations and data processing. Understanding how to use loops with variable limits is essential for flexible programming. Next, we'll find the sum of the digits of a given number. The program repeatedly extracts the last digit using the modulus operator, adds it to a sum, and then removes the digit by dividing the number by 10. This continues until all digits are processed. This technique is useful in many applications, such as digital root calculations and checksum algorithms. Let's look at a real-world application, calculating an electricity bill based on units consumed. The program uses nested if-else statements to determine the rate per unit depending on the number of units. It then multiplies the units by the appropriate rate and prints the total bill. This example demonstrates how conditional logic can be used to solve practical problems. Armstrong number is a number that is equal to the sum of the cubes of its digits. This program checks if a given number is an Armstrong number by extracting each digit, cubbing it, and summing the results. If the sum matches the original number, it's an Armstrong number. This logic is a great example of combining loops, arithmetic, and conditionals. Expanding on the previous concept, this program prints all Armstrong numbers between 1 and 1000. It loops through each number in the range, applies the Armstrong check, and prints those that qualify. This is a practical way to practice nested loops and condition checking in Java. Converting numbers to their word representation is a common programming challenge. This program uses arrays to map numbers to words and handles different number ranges with conditional logic. It's a great example of how to break down a problem and use arrays and string manipulation to achieve the desired output. A palindrome number reads the same forwards and backwards. This program reverses the digits of a given number and compares the result to the original. If they match, it's a palindrome. This logic is widely used in data validation and algorithmic challenges. Taking the palindrome concept further, this program prints all palindrome numbers up to a specified limit. It iterates through each number, reverses it, and prints those that are palindromes. This is a great way to practice loops and conditional logic together. Prime numbers are fundamental in mathematics and programming. This program prints all prime numbers up to 100, and you can extend it to calculate their sum and average. It checks each number for divisibility and prints those with exactly 2 divisors. Understanding this logic is key for many algorithmic problems. Pattern printing is a favorite topic for coding interviews. The first pyramid pattern prints increasing rows of stars, forming a left-aligned triangle. This exercise helps you understand nested loops and how to control output formatting in Java. The second pyramid pattern introduces spacing to centerline the stars, creating a classic pyramid shape. By adjusting the number of spaces and stars on each row, you can create visually appealing patterns. This is a great way to practice loop control and output formatting. Let's explore more intricate star patterns such as hourglass or diamond shapes. These patterns require careful management of spaces and stars, often using multiple nested loops. Practicing these helps you develop a strong grasp of loop logic and creative problem solving. Floyd's triangle is a right-angled triangular array of natural numbers. The program prints numbers in a triangle, incrementing the value with each step. This pattern is a great way to practice nested loops and sequential number generation. Printing numbers in a sequence, such as the sum of 2 variables and updating them in each iteration, is a useful exercise for understanding variable manipulation and sequence generation. This logic can be adapted for sequences and other mathematical patterns. Number pyramids involve printing numbers in a pyramid or triangle shape, often with increasing and then decreasing sequences. These patterns challenge your understanding of nested loops and output formatting, helping you build more complex logic. This pattern prints numbers in a pyramid, but with each row starting from a higher number and decreasing, then increasing again. It's a great way to practice manipulating loop variables and controlling the direction of your sequences. Printing stars in descending order, such as a right-angled triangle with decreasing rows, is a simple yet effective way to practice loop decrementing and output formatting. These patterns are often used in coding interviews to test basic loop understanding. Symmetrical patterns, such as those with stars mirrored across a center line, require careful management of spaces and stars. These exercises help you develop a keen eye for symmetry and logic in your code. Combining stars and numbers in a pyramid pattern adds an extra layer of complexity. You'll need to manage both character and number output, often using multiple loops and careful indexing. This is a great way to challenge your formatting skills. Switching gears to arrays, let's find the largest number in a given array. The program iterates through each element, updating a max variable whenever a larger value is found. This is a fundamental algorithm for data analysis and searching tasks. Finding the second largest number in an array builds on the previous logic. The program keeps track of both the largest and second largest values, updating them as it scans the array. This is a common interview question and a great way to practice variable management. To find both the largest and smallest numbers in an array, the program maintains two variables, updating them as it iterates through the array. This dual tracking logic is useful for a variety of data analysis tasks. This program combines the logic for finding the largest and second largest numbers, ensuring both are updated correctly as the array is processed. It's a great way to practice conditional logic and variable updates within loops. Sometimes, you need to know not just the value but the position of the largest number in an array. This program tracks both the maximum value and its index, printing the index at the end. This is essential for tasks where position matters. Similarly, finding the index of the smallest number involves tracking the minimum value and its position as you scan the array. This logic is widely used in sorting and selection algorithms. Removing duplicate elements from an array is a common data cleaning task. This program compares each element with the rest, shifting unique values forward and creating a new array with only unique elements. It's a practical example of in-place data manipulation. Sorting and separating odd and even numbers from an array is a great way to practice conditional checks and array traversal. The program sorts the array, then prints odd and even numbers separately, reinforcing your understanding of loops and conditions. Matrix addition is a fundamental operation in mathematics and programming. This program adds two matrices by summing corresponding elements, storing the result in a new matrix. It's a great way to practice nested loops and multidimensional array handling. A null matrix is one where all elements are zero. This program checks each element, setting a flag if any non-zero value is found. It's a simple yet effective way to practice array traversal and condition checking. A diagonal matrix has non-zero values only on its main diagonal. This program checks each element, ensuring only diagonal elements are non-zero. It's a useful exercise for understanding matrix properties and nested loops. Linear search is a straightforward method for finding a value in an array. The program scans each element, comparing it to the target value and prints the position if found. This is a foundational search algorithm essential for beginners. Binary search is a more efficient search algorithm for sorted arrays. The program repeatedly divides the search range in half, narrowing down the possible positions. This logic is crucial for understanding efficient data retrieval. Finding the highest common factor (HCF) and least common multiple (LCM) of two numbers is a classic math problem. The program uses the Euclidean algorithm for HCF and then calculates LCM using the product divided by HCF. This is a great way to combine mathematical logic with programming. Calculating the volume of a cube is a straightforward application of arithmetic operations. The program multiplies the side length by itself 3 times and prints the result. This is a simple example of using variables and basic math in Java. Revering the digits of a number is a common programming exercise. The program extracts each digit and builds the reverse number by shifting and adding digits. This logic is useful for palindrome checks and data manipulation. Converting integers to Roman numerals involves mapping values to symbols and subtracting as you build the result. The program uses arrays and a map to handle the conversion, demonstrating advanced string manipulation and data structures. Counting the number of words in a string is a basic string manipulation task. The program splits the string by spaces and counts the resulting words. This logic is essential for text processing and analysis. To count duplicate words, the program compares each word with the rest, incrementing a counter for each match. It then prints the word and its count, skipping already counted words. This is a practical example of nested loops in string comparison. Removing duplicate words from a string involves comparing each word and nullifying duplicates. The program then prints only the unique words. This is a useful technique for data cleaning and text processing. This program counts the occurrences of each word and the total number of words in a string. It uses arrays and counters to track frequencies, then prints each word with its count and the total. This is a great example of frequency analysis in text. Revering a string and checking if it's a palindrome is a classic string manipulation task. The program reverses the string and compares it to the original, printing whether it's a palindrome. This logic is widely used in text validation and algorithmic challenges. Deleting vowels from a string is a simple yet effective way to practice regular expressions and string replacement. The program replaces all vowels with an empty string, demonstrating efficient text manipulation. Capitalizing the first letter of each word in a string is a common formatting task. The program splits the string, capitalizes each word, and joins them back together. This is useful for improving the readability of text data. Splitting a comma-separated string into individual words is a basic string operation. The program uses the split method and prints each word, which is useful for parsing CSV data and similar formats. Converting ASCII values to characters is a great way to understand character encoding. The program loops through a range of ASCII values, casting each to a character and printing the result. This is foundational for text processing and encoding tasks. Replacing vowels with a star character is a simple string replacement task. The program uses regular expressions to find vowels and replaces them, demonstrating efficient use of string methods for text transformation. Printing each character in a string along with its position is a useful way to understand string indexing. The program loops through the string, printing each character and its index, which is helpful for debugging and analysis. Revering the order of words in a string is a common text manipulation task. The program splits the string into words, reverses the array, and prints the result. This is useful for formatting and data transformation. Returning a string as reverse text word by word is another way to practice array and string manipulation. The program splits the string and prints the words in reverse order, reinforcing your understanding of arrays and loops. Finding the difference between the minimum and maximum values in an array is a common data analysis task. The program finds both values and subtracts the minimum from the maximum, printing the result. This logic is widely used in statistics and analytics. Counting the occurrences of each character in a string is a classic frequency analysis problem. The program uses an array to track counts and prints the number of times each character appears. This is essential for text analysis and cryptography.